So, instantiating strings, how hard can it be? Well, it's not that hard, it's just a bit confusing what happens behind the scenes. When C does something behind the scenes, it's not obvious at first. So, the first way to instantiate a string would be with a character array, right? You have your char, and say str, and then array initialization. You might give it a size. I'm gonna give it a size, it doesn't really matter because I'm gonna just initialize it like so. I'm gonna say hello. Alright, I'm gonna also print it to the screen. So printf, %n, and str. Alright, and if I try to run this, we do print hello. What do you know? You might notice that here, printf expects a pointer to a character here. So, and this is an array. And in C, these two are different concepts. And basically, the str variable decays to a pointer. Okay, that's cool. Now, what if I want to modify this array? What if I want to modify this string? Well, I can say str of 0 is h. I just want to have it lowercase. I'm gonna just print it again. All right, so copy and paste. If I try to run this, what do you know? It also modified the array. That's nice. It works. Cool. Now, another way to instantiate the string is with a char pointer. So instead of an array initialization, we say str pointer. And if I try to just print this, it also works, of course. We get hello here. The difference is when I try to actually modify this array. You will notice that I'm getting has stopped responding. I'm gonna get a zigzag or a segmentation fault if I was running with the debugger. Okay, so the program crashed. Why is that? Why is this happening? Well, let's take a look first at the first initialization, the array initialization. Well, this array initialization behind the scenes is just syntactic sugar for, and let me type this out, str equals, and then in brackets, you might know the array initialization used for numbers as well, and it goes something like so, and also adds a \0 at the end, right? And these two are equivalent. So if I try to comment this out, it will also work, and they are exactly the same thing. Okay, now let's take a look at the other initialization, the other way to initialize the string. So if I try to say here char pointer str, yeah, this still breaks the program. But why is that? Well, it's because this behind the scenes translates to something like this. So we start const static char str array, or let me just type a different name, so no name, array equals hello, and then we say char star str equals no name. And these two lines are equivalent to what's happening here. So if I try to run this, you will notice that the program also breaks, right? It's not a perfect equivalent code, right? Behind the scenes, it's a bit different, but let me explain why this happens. In C, every single literal like this is stored in another place in memory, all right? And basically, when you instantiate this, you say, all right, well, allocate this memory and save this somewhere in the memory and give me a pointer to that array of characters, which is going to be str, okay? But when you say this, well, C just interprets it as a shorthand for this one. So instead of C allocating hello in its own memory, it allocates it right there on your stack, on your functions stack. Okay, so what's the difference, right? Here it just allocates it for me, and here's just gonna allocate it on my own function stack. Well, the difference is in the type of memory that it's saving it to. Here we're saving on a stack, so we can read and write. We have permissions for everything. Instead, here we're actually saving in a place of memory that might be read-only. Not necessarily, but in the C standard, whenever we try to modify this memory that is allocated in C for any string literal like this, you get undefined behavior, and that's no good. It might work in some compilers, it might not. It depends on the type of memory, but more often than not, it's just gonna give you a segmentation fault and the program won't run. So don't try to modify strings initialized this way. If you want strings that are on the stack and modifiable, you would like to instantiate it this way. Or if you actually want a pointer, well, what do you know? You can just say char str equals malloc, and then I'm gonna say, I'm not sure, I say like 50 times size of char. I know char is just 1 byte, but just to be safe, and str copy into str and just say hello there. And that would also work if I just comment this out. As you can see here, you also have to, I forgot to actually free the memory. And also don't forget to check if this guy returns null. So if str equals null, you just kind of print error or something. Yeah, alright. So don't forget, if you want to use this type of initialization, you might have to allocate it dynamically or instantiate it like so, right? So these are the two different ways you can actually instantiate a string. Just make sure you remember that if you instantiate it like so, it's actually equivalent to this, and this just refers to basically a constant array, right? In a place, in a read-only memory location. Right, I hope you understand what's happening now with this declaration and this one, and thanks for watching, and see you next time.